Hi guys, today we're going to continue on looking at our financial maths and looking specifically at the recurrence relations and looking at simple interest and formulas in that sense. So obviously we've been looking at arithmetic growth and arithmetic sequences, which is basically patterns. An everyday example of that is the payment of simple interest. So taking out a loan or investing and the simple interest rate you're getting from that. Okay, so today we're going to be looking at the recurrence model for simple interest. Now it looks quite wordy, but it's actually pretty easy to understand. Okay, so VN is the value of the loan or investment after n years. So after an unknown number of years, VN is the value of the loan or investment. R is the interest rate. And now this is really, really important. The recurrence relation for the value of the loan or investment after n years is this formula here. So VO, which is the principal, so the very beginning, the loan amount or the investment amount, VN plus 1 equals VN plus D, where D is the rate over 100 times V0. So that's basically working out what our interest is per year or how much we're paying back in interest. So that's the increment that we're going up or down by every year. I'm going to go through some examples here, but this here is key. That is the recurrence relation. That formula is something that we're going to be needing to use going forward. It looks quite wordy, but it's actually really simple. Okay, so example 1, determine the value of D, the simple interest amount, when 3,000 is invested in a bank paying 4.5% per annum simple interest. Now to do that, all we need to do is put it into this formula here. Okay, so D equals R over 100 times V0. All we need to do is actually substitute our values. Okay, so our 3,000 here is our V0 and our rate here 4.5 is our rate there. So to solve this for this actual question, it would be D equals 4.5 over 100 times 3,000. Now you'd put that into your calculator and that would give you the answer. So I'll do that now for you quickly. 0.5 100 times 3,000. So that equals 135. So that is saying at the end of each year, the interest added to that principal amount of 3,000 is 135. So that's how we calculate D. Now, our second example, Cheryl invests 5,000 in an investment account that pays 4.8 per annum simple interest. The question is asking us to model this using a recurrence relation of the form below. V0 equals the principal, Vn plus 1 equals Vn plus D. Now, to model this, all you are doing is putting our values into this formula. So the principal is 5,000. And then we go Vn plus 1 equals Vn plus D. And we actually have to find out what D is. So again, it's the same thing. So D equals 4.8 over 100 times 5,000. Again, 4.8 divided by 100 times 5,000 equals 240. So D equals 240. So then, instead of doing plus D, you would do plus 240. And that there, this whole thing is a recurrence relation that's been modeled. Okay, so that's how we actually put it into a recurrence relation form. You have to write the whole form, the whole formula, but you substitute your principal and the D, which is you work out by finding using this formula here. Okay, another example is this one here. The following recurrence relation can be used to model a simple interest investment of $2,000 paying interest at the rate of 7.5% per annum. And you can see here, they've actually already put it into the recurrence relation. So as we can see, your V0 is your principal, and then you've got your Vn plus 1 equals Vn plus 150. So obviously that 150 is our D. So that's how much we're getting every year. So that's the pattern that's going on year after year. So use the recurrence relation to find the value of the investment after 1, 2, and 3 years. So basically all you're doing for that, so at the beginning of the investment, you've got 2,000, okay? Because that's how much you're investing. At the end of the first year, so year 1, you've got 2,000 plus our 150, which equals to 150. At the end of year 2, you do the same thing. You're plussing 150 again, so it's 2,300. And then year 3 is the same. It's 2,450. Okay, so you're just adding that D value to our total at the end of every year. All right. Now, the next question is, when will the investment reach 2,750? So you're just going to keep adding that 150 plus 150 plus 150 plus 150 until it gets to anything above 2,750. So it might not get exactly to 2,750, but it will get above it. And that's when you know when the investment reaches 2,750 in value. Okay. And then finally, show that D equals 150 by using the formula, which is obviously the formula we use to find our D. So that for this one would be D equals 7.5 over 100 times 2,000. And that will equal, we'll just double check, times 2,000. 150. Okay, so to work out after 1, 2, and 3 years, or 4, 5, 6, 7, you're just adding our value for D after each year. Okay, you can then use that to work out when the investment will reach the certain amount, and to calculate our D, we use the formula D equals rate divided by 100 times our principal. So that's it for that one, guys. Thank you.